Our modern world runs on semiconductors. They're the silent architects of our reality. The hidden brains inside everything from the phone in your hand to the data centers that power our digital lives. They manage the power grids lighting our cities and guide the satellites connecting our globe. But what happens when the supply chain for these essential parts, a chain stretching thousands of miles to a handful of factories in Asia, snaps? Europe found out the hard way. The great chip shortage of 2021 brought its legendary auto industry to a grinding halt, with high-tech factories falling silent. It was a brutal lesson, exposing a critical weakness, a dangerous dependency on faraway foundries. So now, Europe is fighting back. It's fighting back with a $10 billion deal to bring the world's most important and secretive technology company, TSMC, to its own backyard. This is the story of how that monumental deal went down, the incredible strategic gamble behind it, and the immense challenges that threaten to turn Europe's dream of tech sovereignty into a multi-billion-dollar nightmare. To get why this deal is such a big deal, you have to understand the crisis that made it happen. For decades, Europe was an industrial pioneer. Its factories were the gold standard, its engineering the envy of the world. But while it was perfecting how to build cars and trains, a quiet revolution was happening somewhere else. The balance of power was shifting, not to those who built the machines, but to those who built the tiny silicon brains inside them. The continent had become a massive consumer of semiconductors, yet it had almost completely outsourced their production. By 2020, Europe's share of global semiconductor manufacturing had shrunk to less than 10%. And for the most advanced chips, the ones powering the next generation of AI and supercomputing, that number was basically zero. Nearly all of them were made in one place, Taiwan. For a long time, this system worked. Then, the pandemic hit. A series of freak events amplified the chaos. A fire crippled a massive Renesas automotive chip fab in Japan, and a historic cold snap froze semiconductor plants in Texas. Suddenly, a shortage of older, so-called mature node chips, the 40-nanometer and above workhorses, was enough to stop the production of $50,000 cars. These were reliable, low-cost microcontrollers, sensors, and power management ICs that automakers had long taken for granted. In the chaos, prices for some of these basic auto chips jumped fivefold. Titans of German industry like Volkswagen had to halt specific electric car production lines in Zwickau and Dresden. In a particularly galling image, even fully assembled EVs sat idle on factory lots, useless because a single $2 chip was missing. The economic shockwave was a brutal wake-up call. This wasn't just an economic problem. It was a matter of continental security. This all comes down to technological sovereignty. It has the idea that a bloc of nations needs to control the key technologies that support its economy. In a world of rising geopolitical tensions, especially between the US and China, the question in Brussels and Berlin became terrifyingly simple. What if our supply of chips was cut off entirely? The answer was unthinkable. Europe was dangerously exposed. It had to act. And to do that, it needed the king of the chip industry. Enter TSMC, the Taiwan Semiconductor Manufacturing Company. You might not have heard of them, but they are one of the most important companies on the planet. TSMC is a pure-play foundry, which means it manufactures chips for almost everyone else. Apple, Nvidia, AMD, nearly every tech giant relies on TSMC's unmatched skill. For Europe, landing a TSMC factory, or fab, was the ultimate prize. After intense negotiations, the deal was announced. A landmark investment of around $10 billion to build a state-of-the-art fab in Dresden, Germany. Here's how the money works. TSMC is putting in $3.5 billion, holding a 70% stake. The German government is adding a whopping $5 billion in subsidies. The rest comes from three of Europe's biggest tech companies, Bosch, Infineon, and NXP Semiconductors. They each invested around $500 million to take a 10% stake in the new joint venture, the European Semiconductor Manufacturing Company, or ESMC. This partnership is the secret sauce. Bosch, Infineon, and NXP aren't just investors. They are the fab's most important future customers. Their investment guarantees them priority capacity, which has been likened to booking your seat on the lifeboat before the next storm. It's a direct pipeline from the factory floor to the assembly lines of Europe, says most critical industries. Construction is underway, with the goal to start production by the end of 2027. The fab will produce up to 40,000 wafers a month, specializing in 28-22 nanometer planar CMOS and 16 to 12 nanometer FinFET chips. These may not be bleeding edge, but they are advanced enough for crucial automotive applications like ADAS, sensors, and power management. When it comes online, the 16 nanometer FinFET technology will be among the most advanced nodes produced on the continent, precisely filling Europe's biggest supply gap. This $10 billion handshake is more than just an investment. It's Europe's ambitious, expensive, and incredibly complex answer to a problem that threatens its economic future. But here's the $10 billion question. Can it actually work? Building a cutting-edge fab is one of the most complex engineering jobs on the planet. And moving that process to a new country is loaded with risk. Just look at TSMC's other mega project, the $40 billion fab in Arizona. That project has been hit with soaring costs, construction delays, and a major culture clash between TSMC's grueling work culture and American labor practices. So, is the German project headed for its own disaster? Backers will tell you that Germany is different. The location, Dresden, is the heart of Silicon Saxony. For decades, it's been the center of Germany's microelectronics industry, already home to major fabs for Infineon, Bosch, and global foundries. The region boasts a cluster of over 2,000 semiconductor-related companies. TSMC's arrival cements it as Europe's undisputed chip capital. In theory, Germany's reputation for precision engineering and its existing ecosystem should be a much better fit for TSMC's demanding standards. But the challenges are still huge. The fab is expected to create 2,000 direct high-tech jobs, putting immense pressure on an already tight labor market. A $5 billion subsidy is also politically loaded, with local debates flaring up over environmental impact and water usage. Furthermore, to satisfy the EU, ESMC must operate as an open-access foundry. This means it can't be a closed club for its main investors. Smaller European firms, startups, and even research institutes will be able to order chips. This is meant to broaden Europe's entire chip ecosystem, but adds another layer of operational complexity. And to lock in its European strategy, TSMC has also opened a chip design center in Munich, which began operations in the third quarter of 2025. This highlights the central challenge: bridging the cultural and operational gap between Taiwan and Europe. The success of the Dresden fab won't just depend on concrete and steel, but on merging two very different worlds of work. The Dresden fab isn't happening in a vacuum. It's a move on a global geopolitical chessboard. This investment is Europe's direct answer to the United States CHIPS and Science Act, a $52 billion program to reshore chip manufacturing. The $5 billion subsidy for TSMC, covering 50% of the project's cost, is one of the largest granted under the EU CHIPS Act. And it's part of a wider subsidy arms race, not just globally, but inside Germany itself. Intel is securing an even bigger subsidy, reportedly close to $10 billion, for its own megafab in Magdeburg. In the new global reality, Massive government support like this, which mirrors subsidies in the US and Japan's 40% coverage for fabs, is now the price of entry. This is all part of the EU Chips Act, a $43 billion plan to double Europe's share of the global semiconductor market to 20% by 2030. But that ambition is colliding with a harsh reality. A recent report from the EU's own auditors warned this target is very unlikely to be met, with forecasts putting the continent's share closer to 11 or 12% by 2030. Strategically, this move pulls Europe deeper into a Silicon Shield alliance. TSMC's overseas fabs are located only in the US, Japan, and now the EU, all key security partners. This embeds TSMC into Western economies, a move encouraged by Taiwan's government as a form of foreign policy, allowing the EU to strengthen ties with Taiwan without making explicitly political statements. However, this is a deliberate strategy from Taiwan to remain irreplaceable, ensuring its own centrality by keeping the most advanced 3-nanometer and 2-nanometer production exclusively at home. This underlines the central paradox. The Dresden fab's output of 40,000 wafers per month, while significant for Europe, is a rounding error compared to the output of TSMC's megafabs in Taiwan. It gives Europe some resilience, but it's far from self-sufficiency. Still, it secures a supply for its world-leading auto industry, creating a gravitational pull for talent and making Europe a more resilient third player in the tech rivalry between the US and China. So, it all comes back to this. Europe, faced with a crisis that exposed a deep vulnerability, has placed a $10 billion bet. The TSMC fab in Dresden is a monumental step, a fusion of Taiwanese tech mastery, German industrial might, and European political will. It's an attempt to partially reverse decades of globalization and bring home a capability now seen as vital as steel or energy. If it works, it will secure thousands of high-tech jobs, anchor a critical supply chain on European soil, and stand as a powerful symbol of the continent's renewed industrial ambition. But let's be clear, this project won't deliver total technological sovereignty. Europe is betting billions, but will still fundamentally depend on Asia for the most advanced chips for years to come. The challenges are real, and that enormous public subsidy will be under a microscope. Which leaves us with one final open question. Is this $10 billion deal a masterstroke of industrial policy that secures Europe's place in the future? Or is it the most expensive subsidy in German history for a factory that will make chips that are already generations behind the cutting edge by the time it's fully running? The concrete is being poured in Silicon Saxony, but the ending to this story is far from written.